Hello, and welcome to this presentation on the Mechanical Engineering graduate programs at Tufts University. My name is Robert White. I'm the graduate program director in the department. I'm an associate professor here, and I've been at Tufts for about 12 years. I work in the area of micro and nanosystems, sensors, and actuators. I want to describe to you the four main degrees that we offer at the graduate level in mechanical engineering. We have a Master's of Science with Thesis degree in mechanical engineering. This is a 10-credit degree which takes 2 years to complete. We also have a Master's of Science with Thesis in Human Factors Engineering. It takes about the same time to complete. We have a Master's of Science without Thesis in both Mechanical and Human Factors Engineering. This can be completed in 9 months of full-time study. And we offer a doctoral degree in Mechanical Engineering. I don't want to spend a great deal of time describing all the courses that are required for the different degrees. You can see the requirements on the websites, which are linked at the top of each of these slides. But very briefly, the Mechanical Engineering Master's degree with Thesis requires 7 classes, which are technical classes, attendance at a weekly seminar, and a 3-credit thesis, which usually takes about 2 semesters of work or 2 semesters and a summer to complete. The Human Factors with Thesis degree is similar, 7 technical classes, seminar, and a thesis. The Master's of Science in Mechanical Engineering without Thesis is slightly different. This degree is intended to be finished in 1 year of study, that is 2 semesters, and requires 10 classes. There are still 7 technical classes, similar to the thesis degree, but now instead of a 3-credit thesis, there are 3 professional development classes. These include a business communications class and then 2 electives which can be selected from the list you see. These classes are mostly taught by the Tufts Gordon Institute for Engineering Management. The Masters of Science in Human Factors without Thesis is similar. 7 technical classes are required, plus the 3 professional development classes and seminar. The department also offers a PhD degree in mechanical engineering. This degree can be pursued by students already holding a Master's of Science degree in mechanical engineering or a related discipline, in which case the student would complete 5 classes, pass the PhD qualifying exams, attend seminar, and of course the main part of the activity would be generating the PhD thesis. Students without a master's degree could either come to the program and first do a master's degree and then pursue the PhD, or could come to the program and do a direct PhD. In this case, the student would not receive a master's degree along the way, would not write a master's thesis, would take 12 classes, pass the PhD qualifiers, attend seminar, and write a PhD thesis, receiving only a PhD degree. I want to speak briefly about tuition for the program. The main thing that you need to understand is that tuition is charged for master's students primarily for 2 full semesters. As of the current academic year, 2017-2018, master's students are charged $25,260 per semester for the first 2 semesters of study only. Additional semesters beyond the first 2 full-time semesters that may be required are charged only a continuation fee of $800. So if you stayed 3 semesters to complete your non-thesis master's degree, for example, you would pay $25,260 for each of the first 2 semesters and then be charged only $800 continuation fee for the 3rd semester. This is true whether you're doing a full-time thesis program or a full-time non-thesis program. If you were paying for the PhD program out of pocket, you would be charged a rate of $15,578 per semester for 9 full semesters. However, most PhD students receive financial assistance from the department, which I will talk about in the next slide. If you're interested in part-time graduate study, you will be charged $5,052 per course. Since the master's degrees are 10 courses, that means that the master's degree costs about $50,000, whether you're doing it full-time or part-time. In addition to the tuition, there are also additional health fees and student activity fees that are assessed. As I mentioned on the previous slide, financial assistance is available from the Department for Graduate Study. These awards are primarily given to PhD students, although in some cases, thesis-based master's students might receive financial assistance. There are 2 main mechanisms. The first is the teaching assistantship, or TA. These are teaching appointments that are 9 months in duration. 20 hours per week of teaching effort is expected. The TA will receive a $2,550 per month stipend for the 9-month appointment. Full tuition scholarship is included. TA offers are made by the department at the time of admission. So if you receive a TA, you should see this in your offer letter. but if you're not sure, please feel free to ask the department. The second main mechanism is the Research Assistantship, or RA. These are not offered by the department, but are offered by individual faculty members. They are variable in length and vary in the amount paid per month, depending on the faculty member's needs. The current minimum stipend is $2,300 per month, although most faculty members pay more than this. RAs include full tuition scholarships. The RA offers are made by individual faculty members off of their grants and contracts. So the important thing to know is if you're looking for an RA, make sure you're speaking to individual faculty members in your area of interest. Please look at the website and see the faculty research areas and contact faculty directly to ask about RAs. Some RA offers may be made at the time you are admitted with the offer included in your offer letter, but it's always possible that a faculty member gets a new contract or grant at any time and could make a new RA offer at any time. So just make sure you're talking to faculty. We have 19 full-time and 4 part-time faculty members in the department. This is a list of all of the names. I will talk briefly about some of the different research areas, which I hope is what will get you excited about the department. The reason you should come to our department and work with us in graduate program is because you're excited about our research and you want to get involved. Bill Mesner is an expert in automatic control systems. In the past, he's worked on data storage systems. He's currently working on robotic systems, such as the Baxter robot you see on the top right, and also working on automation for biological research. Mark Kachanoff is an expert in fracture mechanics and the micromechanics of materials. He works on modeling of fracture and modeling of micromechanics. Anil Saigal is an expert in materials engineering and manufacturing and works on a variety of problems in material science and manufacturing processes. Igor Sokolov is an expert in nanomechanics. He works with atomic force microscopes, soft condensed matter, and biomedical research at the nanoscale. You can see a picture on the top right of the mechanics of cells for cancer detection, where they're pressing on a cell and determining its mechanical properties at the nanoscale. Chris Rogers is the department chair. He works in the areas of robotics, musical instrument design, and engineering education. You can see at the bottom right a little picture from the Center for Engineering Education and Outreach. This is an excellent center in the School of Engineering that works both on educational technologies and on learning sciences, including the music engineering program. Behruz Abedian is an expert in fluid mechanics. He also works on electrokinetics and thermal fluid systems. Luisa Chiesa is an expert on superconducting materials. She works on sustainable energy problems, particularly superconducting materials used for magnets and power transmission, and also energy generation. She does a lot of experimental work on the mechanics of superconducting materials. Mark Hodis is an expert in heat transfer and the cooling of electronics. He also works on problems in sustainable energy and thermodynamic manufacturing processes. Doug Mattson is an expert on materials science. He works on solidification processes, including zero gravity or low gravity solidification of metals. He also works in thermal manufacturing and machine design. At the bottom, you can see a picture of one of Professor Mattson's experiments. Here they're working on a solidification experiment where they've inductively heated a metal to the melting point and suspending it in a magnetic field. You can also see on the right a picture of one of Professor Chiesa's experiments where she's working on the mechanics of superconducting materials and thermoelectric module from Mark Hodis' lab. Professor Reif is an expert in navigation, robotics, and autonomous systems. He works on the automated landing of aircraft, among other things. I'm an expert in micro and nano electromechanical systems. I work on sensors, dynamic systems, and acoustics. In the center, you can see a picture of one of our MEMS microphones. Professor Guasto is an expert in fluid mechanics, including the swimming of cells, as well as microfluidics. At the bottom right, you can see a picture of a swimming cell, which he's analyzing using particle tracking velocimetry. Professor Kemmerling is an expert in fluid mechanics and medical fluids, biofluids. She works on blood flow in the human body. Kristen Wendell is an expert in engineering education and learning sciences. She works on the areas of design and understanding engineering education and learning. Professor Zenyuk is an expert in electrochemistry. She works with fuel cells and energy generation and storage, as well as imaging of micro and nanostructures in electrochemical systems. Professor Lisk is an expert in design and testing. He does a lot of mechanical design and machine design problems. You can see an example of some biopolymer screws that were made for a facial surgery. Dan Hannon is an expert in human factors engineering. He works on airspace systems, including air traffic control and other similar problems. Professor Misra is an expert on GPS and satellite navigation systems. He teaches a very popular course on GPS, has a book on GPS, and does research in the area of navigation and GPS, working a lot with Professor Reif. Professor Zimmerman is an expert in mechanics and polymers, polymer processing, and batteries. He has a very active research effort in polymer batteries. Deborah Sunter is a new member of the department who will be joining us in September. She's an expert in renewable energy systems and particularly science and policy interaction at the national level, so understanding how academia, industry, and government work together to build power systems. James Introligator is professor of the practice in human factors engineering. He's an expert on design, human factors design, as well as marketing, branding, and consumer perception. So those are some of the areas that our faculty are working in. We hope that you will apply to our programs. We think that we have a very dynamic department with a lot of exciting work going on. We hope that our students find us to be friendly and approachable, and we think that we will prepare you well both for your careers in the professional world through our professional development classes in our master's program, as well as our thesis master program, and we think that we will also prepare you very well for careers in industry, academia, and government doing exciting research if you stay with us for a PhD. Please do apply. Please check out our website. We have more information on what we're doing, and I'd be very happy to hear from any of you. My email address and a link to my website are on the front page of this presentation.